Hello guys, welcome back to my channel. Still the same boy Fortune. Today we'll be taking data visualization with Pandas. I will be listing the libraries in Python that are used for data visualization. But for today, we'll be doing only Pandas data visualization. There are four libraries we use for visualization in Pandas in Python. As you can see, we have the. Let's start importing them. You have the pandas first, post pandas as PD. Then you have the matplotlib, the imports matplotlib dot pyplot python plot as plt, and then we have the numpy, which is used for mathematical calculations with visualization. The numpy as np. And then finally we have the cbone. So now these are what we'll be using for visualization and other tertiary aspect of data analysis, and you'll be seeing a lot of this in higher places. So this is the basic. Visualization is one of the very important aspects of data analysis because you have to represent your data in pictorial form. So representing pictorial form requires you visualizing the data. Do you get me? So that's it. So first thing first, we have to import our file. That's our data frame. So you read it in. You see our data frame. So importing it, read. Now, as we used to do CSV, now it's no more a CSV. This is an Excel file because I coupled it in Excel, Microsoft Excel. So we import it as Excel. As you can see, if you look at the end of it, as you can see, if you look at the end of it, you have XLSX, which means it's an Excel file. So data frame, we call our data frame. Now this is our data frame. Our data frame consists of these columns: steel, cast iron, aluminium, brass. This is a data frame that consists of material strength. So first thing first, before we go on, we would have to set our index. We set our index as the serial number. Our serial number as the index. So you see df.setIndex, so that we can visualize well. It will by default setting that a particular column as index by default gives it maps it to the horizontal part of the chart, be it the line chart, the bar chart, the histogram, the pie chart, and all of that. So we'll be doing them in a bit. So set index as ISN. Now let's in place it true. Boom. So let's return our data. Now our serial number now has been set as the index. So now first thing first, the syntax we use to plot is called df.plot. Df.plot, that's the syntax we use to plot data frames. Df.plot. So now just writing df.plot returns a line chart by default. As you can see, if you go to the properties of plot, you have the X label, you have the Y label. These will tell or label each part, both the horizontal and the vertical part. So the horizontal part being X would be labeled and the vertical part Y. So by default, it's the place we set as the index that will be labeled as the horizontal part. And as you can see, the kind of plot you can produce: line by default, as you can see, bar, vertical bar plots, which is bar chart, then the bar H, horizontal bar plots, then you have the histogram, you have the bar box plot, KD and density. Will be skipping these, moving to the area, pie and scatter plot. These are the basics I'll be teaching you. Maybe as time goes on, I'll be teaching you other type of plots. So first thing first, let's plot it. We can state the kind of plot we want by using the kind, as you can see in our properties. Kind, you have the kind. So setting our kind to line returns the same thing. So be cautious not to use the capital letter L to start it as a line. So then you can run this. As you can see, it returns the same thing the same thing. Now this is our legend. Each line represents each column. You have the steel, blue being steel, orange being cast iron, green being aluminium, red being brass, and purple being copper. Those are the very basics. Now you can now state X label. So what do we state? Let's make it points, and Y label serial number. Alright, another thing I forgot to tell you is as we scroll down, we can see there's figure size. We can format the figure size, we can increase it and make it small or reduce it. Then there's also the chart title, so we'll be using all of that. Let's go on to use the fixed size. So fixed size is used in tuple, as you can see, 6, 4. Let's make it smaller, or let me just make it 10, 8, 10, 8, and then title, chart title, say our line charts, boom. Increase size, as you can see now it's bigger, and you can see we have the chart title now, which I named line chart, and every line has is being represented by every column is being represented by a line in this chart. As you can see, you have the steel, this, you have the cast iron, this is orange, you have the green, and you have this. Another thing now is that we can split this these lines to have, so each line will be represented in a graph, a chart, in an individual chart. So by using the subplots, setting the subplots to true, we can split this chart into various 5 different charts, each chart having each column being represented by each line on this general chart. So if we set the subplot to true, subplots true, okay, as you can see, it's being split. Now still has its own chart, this has its own, this has its own. What did I do? Did I just Y label should be point, X label should be serial number, Y label should be plot point. But same thing. So X label serial number, so same thing we'll do here. Change X label to serial number and Y label to points. I wrote points. Mistakes happen. Okay, we'll run this. As you can see, these are being split into different kinds of into different charts. In each chart you have each column. Do you get me? So it's the same scenario we use in pie charts too. You cannot just plot pie chart like that. You have to state or specify the particular column, or if you want to plot a general pie chart, you have to split it. It has to be split using the subplot true. So moving on, we'll be taking the next kind of chart, which is the bar. Can change this to bar. So bar chart. Let's go and rename it. Oh, sorry, this is using the subplots. I forgot to change the subplots to remove the subplots. You can change it to false. So now we have one, just a particular chart. As you can see, this is a bar chart. Returns the bar chart of each serial numbers. In each serial numbers there are 5 materials, as you can see, depending on how you want to visualize it. If you want to visualize it in this bar form, and there's another way to plot the bar chart. As you can see in our properties, there's the bar chart horizontal. This returns the horizontal bar chart. We'll be testing it out. bar h. Okay, boom. So as you can see, this is in the horizontal form. So you can also represent it like this. You can also do it like this. You can write dot plot dot bar h. Returns the same thing. Can you see? There's literally no difference. So I'm copying the two for you. So you can be versatile and vast. You can have vast knowledge in data visualization. Kind is equals to bar h. So same thing. As you can see, let's reduce our size. That's why I love manipulating this. So it's been reduced. Now we'll be moving on to the next, which is histogram. So histogram, we can specifically state it. Histogram. And this is a histogram. So in histogram is different because everything is being joined. Each bins are being joined together. So we can we can specifically state our bins by setting the bins. These bins are the number of blocks we have. So you have here is by default it is 10. It has 10 bins by default. So we can state it. As you can see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's 10 bins. So now we can state our bins. Let's say 20. Bins are needed if you want to spread the data. They help in data spreading, and while visualizing it, you can spread the data by visualizing. So these are the. So if you want to, let's see if subplots can work. It should. As you can see, it's been scattered here, but you know what subplots are by now. So let's set it to false, or literally remove it. Boom. Can you see? Returns back to normal. We can set our bins to 30 or even 100. 30 now. You can set it to 100. Just this signifies the spread of data. They help you to spread data well. Giving the correct bins to a particular visualization or a particular chart with histogram tells you how experienced you are. So you should know by now that you are in the, let's say, the intermediate level, or advanced data analyst. They can specify their bins, and some companies may use it as an interview to check you or to see if you can really spread data well in a way that anybody that can gather information about the data from your chart would look at the amount of bins you set it, or the data spread, of how you spread it, and see how experienced they can gauge your experience just with that. So I set my bins to 20 to avoid unnecessary noise. When the bins are too much, you have noise, and when it is too small, it's being oversimplified. So you need to make it moderate. Do you get me? You have to make it moderate. You should use your sense. So I recommend 20 or 25 or 30 at max if you want to. I use 20 most times. What do we have again? In the next, we have the box plot. This is the box plot. Let's go over to the box plot. Kind box. So now, for the box plot now doesn't do like this. Doesn't have legends like keys. Do you get me? So box plot literally returns each column in the horizontal segment. Let's try it. I have to erase these bins. Erase these bins and erase box plots. Oh, let's change it to materials. So this signifies the material. Box plot is used to signify the percentile and the quartile. As you can see, this is the lowest, the highest, and the middle. You have 75 and the 25% range, 0, 25, middle, 75, 100. Do you get me? So that's what it's you can use to represent a data by the quartile or the percentile. Do you get me? So you should know as a data analyst. In statistics, we use percentile and quartile to look at how spread the data is. They are like the range. We have mean, median, mode, and range. The median, the mode, they are central tendencies. This is also used. You can also use this as the median, which is the middle point. The middle point. Okay. Quartile can signify the median, because the middle point in quartile, which is 2, signifies the median, and the percentile is 50. So this is 50% of still. This is the lowest quartile, so it's being skewed below 50 here. So the midpoint of here is below 50 here. Next, cast iron for aluminium, brass, and copper. It does it. So we'll be looking at our next chart we can plot, which is the area plot. So we'll copy this. Just kind of area. So for the area plot, we can now go back to normal, because the area plot will bring out to have something like this, our legends, and each area, or it's not return a line, it's an area. So each column or each material will be represented by an area. So materials. So what do we have? Area plot. Boom. Now, as you can see, it doesn't return a line like the line chart. Now, being stated, you can now use area plot for some data that you want to spread, or for just finis. You can also use it for aesthetics, because sometimes companies can determine how experienced you are from the way you present your data, how beautiful your data can be presented. As you can see, this is well colored and well visualized. Let's move to the next. The next should be pi. Okay, and after pi we'll do this scatter, and that will be all. So for pi is a little bit different. You cannot just say boom pi now. As in others, you can state the x and y label. Do you get? But pi, no. Pi says no. Return, show you an error. It said you need a y column or a subplot. A pie chart returns a pi of a particular column. Do you get? It doesn't join columns together. If you want it to be joined, then you have to create a subplot which will return different pies of different columns. Then what it gives you, what it signifies, we need this y column to be calculated on the pie chart, and then the index. That's why I said indexing is very important. The index will be set as the marker or as the label. Do you get me? So you clear this. So say y. Let's pick one column still. So pie chart. As you can see, for only this, can you see what I'm saying? So you have the index. These are the index, which is the serial number we used. We set the serial number as the index, and this represents the still, each data point in still. So the still in the first serial number, that's the first testing for still. So it returned 46.5, 49, 52, 48, and 55. That's why you could not notice any difference inside, because the numbers are close. But if you really look at it, you will see that their size varies, and this represents only still. Then you can go for cast iron and others. Still, you can go for cast iron. same thing. Let's see F. Oh, sorry. DF. Alright, this is for cast iron. Same thing. You can only return for a particular column. You can only plot a pie chart for a particular column, not more than one columns. And if you want to plot for more than one columns, you have to use the subplots. Set the subplot to true. You remove this subplot. For it to return. So it returns. So let's increase the size 10 and 8. So as you can see, this return is subplot of everything for steel, for cast iron, for aluminium, for brass, for copper. So you can either set the subplot to be this or you return it individually. So that's how to represent it. And then finally, we have the last but not the least. We have the scatter plot. So let's use this as scatter plot. Come back here and copy this. So the scatter plot has various scatter. So let's put the title on it. Scatter requires an X and Y column. Okay, sorry. So scatter plot requires X and Y column. It's just like what do you call it? It's just like pie chart. So you need an X and Y column. So X should be a serial number. Y should be probably steel. See for steel. It's not returning. Still giving us error.